Take two. Okay. So with the renin-angiotensin mechanism of aldosterone release, what we're talking about is control of blood pressure through this hormone called aldosterone. And so we always want to have adequate blood pressure. If we have blood volume decreasing or blood pressure decreasing, please write this out on your exam. So if we have, like, for instance, a blood vessel and we have this much blood in it, that is the blood pressure. We haven't covered the blood pressure chapter yet. Pressure from blood forcing on the walls of the actual blood vessel. Say we have that same blood vessel, but we have half as much blood in it, then blood pressure is going to drop. That's why blood volume and blood pressure are directly related to one another. You can have, if you have a drop in blood volume, you're going to have a drop in blood pressure, but you can't have a drop in blood pressure without a drop in blood volume. So that's why I say if you drop blood volume and drop blood pressure, that's going to be our main release here. What's going to happen is the kidneys figure out that we have this drop. Kidneys detect the drop in blood volume and blood pressure and release renin. Renin is a hormone. Renin is a hormone. The kidneys release a hormone called renin. And when renin is released, what it's going to do, there's already a protein that's floating around in your blood that your liver made. And it's called angiotensinogen. So now we have renin in the blood when we did not have renin before. Hormones travel through the blood. And already sitting in the blood is something called angiotensinogen. And what renin is going to do is it's going to convert that angiotensinogen, angiotensin-ogen. This part means inactivated. So if you notice, if we take the ogen out, if we activate it, it's going to be angiotensin. That's that word up here. So angiotensinogen is the inactive form of angiotensin, and it's just floating around in your blood. And when we release renin from the kidneys, it converts angiotensinogen to angiotensin 1. And why do we call it angiotensin 1? Because there are actually two different types of angiotensin. This angiotensin is now in the blood. We've converted angiotensinogen to angiotensin 1. Now that we have this angiotensin 1 floating around your blood, as it goes through the capillaries in the lungs, and there's some other organs, the capillaries are capable of doing this, but angiotensin 1, just going to say, goes to the lungs, lung blood vessels, and is converted to angiotensin 2. This is our big player. Angiotensin 2 is super important. Now, how did the lungs convert angiotensin 1 to angiotensin 2? Through an enzyme. So I have angiotensin 1 goes to the lung blood vessels and is converted to angiotensin 2 by this specific enzyme. It's called angiotensin converting enzyme. Imagine that. Nice name, because then we can just take it down to ACE. Write it out once. Okay, so that angiotensin converting enzyme converts angiotensin 1 to angiotensin 2. Now, angiotensin 2, this guy, it can cause vasoconstriction. So what is vasoconstriction? Vasoconstriction is like this. If we have a blood vessel that has a low amount of blood in it, if that blood vessel gets smaller, it goes from the big lumen to a small lumen, then that same amount of blood appears to be like this, up to this level. Here we have like this. We've got low blood pressure in this blood vessel. But if we cause it to constrict, now we have the same amount of blood, but it's really forcing on those walls, and so that increases blood pressure. Angiotensin alone is a potent angiotensin 2 is a potent vasoconstrictor. It can cause potent, powerful vasoconstrictor. So that in itself is going to increase blood pressure. Well, but this question is asking you, how are we going to cause the release of aldosterone? Angiotensin 2 can also cause the release, release of ADH, antidiuretic hormone. Antidiuretic hormone does this. It takes blood volume and it increases it through the kidneys. We know that from this past chapter. But more importantly than that, it causes the release of aldosterone. That's the main thing that this question is going for. So aldosterone, because of angiotensin 2, aldosterone is released by the adrenal glands. And aldosterone is a hormone, and it is going to target the kidneys. So the kidneys started all this. We start with the kidneys. They release a hormone that causes a release of a hormone that's going to go back and influence the kidneys. So aldosterone is released by the adrenal glands, and it targets the kidneys. It goes back to the kidneys. What does it tell the kidneys to do? Specifically, the kidney tubules, under the influence of aldosterone, resorb sodium. That means the kidneys make urine, correct? And in the urine, we have sodium. Now, if we take sodium out of the urine and put it back into the blood, guess what's going to follow? Water always follows salt. Water is going to follow. So if we take water out of the urine and put it back in the blood, that increases our blood volume. That does this right here. So really what the kidney tubules are doing is they're resorbing sodium. This is important. And secreting, that means getting rid of, because sodium and potassium always go in different ways. If we retain sodium, we get rid of potassium. If we retain potassium, we get rid of sodium. They work in different ways. And so kidney tubules resorb sodium and secrete potassium. And by secreting potassium, that means we're putting it into the urine. Resorbing means we're putting it from the urine back into the blood. Secreting it means we're taking it out of the blood and putting it into the urine. It's sort of our replacement electrolyte there. So the kidney tubules resorb sodium, and then water follows. Water follows. And this increases blood volume. Therefore, it increases blood pressure, because anytime we have higher blood volume, we're going to have higher blood pressure. These two guys are directly related to one another. That's it. It's not too bad. I mean, it's a beautiful system. Beautiful. Okay, this is the third question for the endocrine system. And yeah, I'll just leave it at that. It's one of my favorites because it's all about blood pressure.